So we're out here in the Great Barrier Reef testing the cloud brightening concept. Cloud brightening concept is that maybe we can take seawater, atomize it, which is sprayed out from this turbine here, and that those droplets will mix up with the atmospheric boundary layer and brighten the clouds a little bit. If we can brighten the clouds just a little bit over the whole summer, then we can cool down the water enough to stop some of the coral bleaching. And there's bleaching all around us happening right now. It's the third mass bleaching event.
Imagine if Harvey, Irma, Jose, Katya, Lee, and Maria hadn't been so powerful. Well, Stephen Salter is working on a plan. It's crazy, but if hurricanes are fueled by warm water, what if we could cool down the ocean, or even the world? Salter thinks we can, by making clouds brighter using the sea itself. It's called Marine Cloud Brightening, or MCB, and was originally thought up by climate physicist John Latham. Here's how MCB could work. Wind-powered unmanned vessels spray very fine droplets of seawater into the air. As they evaporate, salt crystals are dispersed throughout the atmosphere via turbulence. The humidity of the atmosphere causes the salt to latch on to existing clouds, making the clouds ever so slightly brighter. You won't notice a difference. The threshold is below what the human eye can see. But this increased brightness reflects more of the sun's rays back into space, thereby lowering surface temperatures of the sea. This theory is possible thanks to the Toomey effect. The Toomey effect states that if there are two clouds with the same amount of water vapor, the one made up of more, smaller particles will have a higher albedo. Hurricanes form by sucking in moisture from the ocean, as well as taking in air. As surface temperatures increase, seawater evaporates more easily and feeds the storm faster. This also causes the air to heat up, making the hurricane even stronger. Salter has calculated the minimum temperature hurricanes need to form, 78.8 degrees Fahrenheit. If the ocean's surface can be cooled below that point, tropical storms theoretically won't form. But Salter doesn't want to lower temperatures enough to eliminate tropical storms, since they can provide what he calls useful rain. In fact, he doesn't want a temperature drop of more than 3 degrees Fahrenheit. We have to be able to properly filter the water. There's a lot of pollution and plastic in the sea that we don't want getting into our atmosphere and the air we breathe. Marine cloud brightening could potentially mess with weather patterns that rely on ocean surface temperatures.
It's the process of wave breaking, the normal beautiful swoop and dive, which actually pushes under the water a lot of air, which then rises to the surface again as bubbles. And that's the white stuff that we see when waves break. And each one of those bubbles ejects hundreds or thousands of little droplets, which happen to be about the size that we need for our experiments. So we have to find a way of generating seawater droplets of the same size, but in much greater quantities.
Scientists first began trying to manipulate clouds in 1946. They found that by firing tiny particles of silver iodide into rain-bearing clouds, they could induce rainfall. Stephen Salter has been working with clouds since the 1980s, but the challenge now for him and John Latham was to figure out how not to make it rain, but to increase cloud cover.